Hi guys, my name is Vinay Jain and today we're going to be discussing Leetcode question 100, same tree. So the question is, given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So what does this question mean? So let us assume these are the two trees we have. P is the first tree and Q is the second tree, and one in both trees are the root nodes of their trees. So we check the value at the current nodes. So P is pointing to this node and Q is pointing to the current node of root node of second tree. Then they both are 1. So their value is the same. So therefore till now they are the same tree. So at recursion depth 1, P dot val is equal to 1, right? I'll write this with a different color. P dot val is equal to 1, which is also equal to Q dot val, which is also equal to 1, right? So therefore we proceed to the next recursion depth. I'll just write recursion depth as RD. So this is where now P comes. So this is basically now where P points. Let us assume this is the new pointer of P and this is the new pointer of Q. So now we are here. So at recursion depth RD is equals to 2. What is the case that we have? What is the P dot val that we have? It is 2, right? This is on the left side. P dot val is 2, right? Which is, sorry, my bad. And what is Q dot val? It is 2. Are these both the same? Yes, they are the same. So on recursion depth 2 on the left side, the trees are still the same. So we proceed further. We check in the left child nodes of the current nodes in each tree. So P becomes here and Q is now pointing to here. Notice that at recursion depth 3, left side, P is equal to null. P is equal to null, which is equal to Q as it is also null, right? Since they are both on the left side and they both are null, so therefore they again are the same tree. So now this function then returns true to its parent calling function at recursion depth 2 on the left side. So basically this is returning true to its parent function, true. And now once we reach here, P is again pointing. So this is again where P is pointing and this is again where Q is pointing in the second tree. So now we check the right child of their current node. So this is where we next check, are the trees still the same? So again, the right child of these both nodes are again null. So at recursion depth 3, right child of both these nodes are still null and again they are the same. So therefore this also then returns true to its parent calling function. So this also then returns true to its parent calling function. Since both have returned true, that means the subtree of this node and in this node in the second tree, they both match. So this returns to its parent calling function, which is essentially here. So this essentially means that the node 2 and its subtree in the first tree and the node 2 in the second tree and its subtree, they both are the same, they all match. So therefore till now we have on the left side of node 1 in both trees we have a match of the same tree. So then we check in the right hand side of the current node. So essentially when we have returned to this node, P is now pointing here. This is where P is pointing and this is where now Q is pointing. Now once we have done this, we check into the right side of both nodes since we have explored the left child and found a match there. So once we have done this, sorry, my bad. So on the right hand side of both trees, this is where now P is pointing and this is now where Q is pointing. They both are a match, right? So this is again a match at recursion depth 2 at right side. P dot val is 3 and Q dot val is also 3 and they both are a match, right? So we then explore its subtree, which is in the left child of the current node of both trees. So the left child of the current node is null and this is also null, which is essentially where Q is pointing and P is pointing. Since in the first tree at this side where I'm highlighting, in the second tree where I'm highlighting, they both are null and they both are on the left side. So at recursion depth 3 on the left hand side, P is null, Q is null and they both are the same, so there's a match. So this returns true to its parent calling function. And then we check. So now we check the right hand side of this node since we have explored the left hand side, and now P is pointing here. So Q is pointing to this null node and P is pointing to this null node in the first tree. Again, to reiterate, we're exploring the right child nodes of node 3 in both trees, which are both null, and therefore this also returns true to its parent calling function, and this also returns true to its parent calling function. So essentially this is what the diagram now looks like. Yes. So now that both left and right child nodes of the current node 3 have returned true, that means the subtree of 3 in both trees are the same. This then returns true to its parent calling function, signifying that in both trees in the right hand side there is a match. They are the same tree. Now the control comes back to the root node 1 in both trees, where now the program evaluates since it has returned true from its left child as well as from its right child. So that means in both trees. So that means this node and its subtree, they both are the same and there's a match. So since we do not have any more nodes to explore, so therefore we conclude our algorithm and the algorithm returns true. Since all subtrees of every node have seen a match and are same and have returned true, so therefore the root node then of both trees are also returning true to their parent calling function. So this is how the algorithm works. Let's see another example, a small example to understand one edge case in this scenario. So the edge case is, let us assume this is the kind of tree that we have. 1, 2. So this is the first tree. On the left child of 1 we have a node 2, and there's a second tree in which the left child is null but the right child is 2. So again, note that in first tree the left child of the root node is 1, this is P and this is Q. In the first tree the root node is P and there's a left child 2 but no right child, and similarly in Q the root node has one right child but no left child, and this is for the second tree. Now similarly we proceed ahead. We first check if the current nodes are a match or not. Yes, they are a match. So we check in the respective left child nodes of the current node. So this is where P is pointing now, to the node 2 in first tree, and Q is pointing here, which is essentially a null node. I'll write this again. This is a null node and this is where Q is pointing. So now we check whether at recursion depth equals to 2 for the left side, right? So this is what we're checking, right? P dot val, which is equal to 2, right? Is that equal to or not to Q dot val? First of all, there is no val of Q because Q is a null node. So Q is null. So therefore we cannot make a match. So this is not a match. So therefore this returns false. Why this is an edge case? Because I just wanted to show that if there's one valid entry and one invalid entry, let's say one has a valid value and the other one is a null value, so therefore null node can't be matched with a valid node, right, with some value. So therefore this is not the same, so this will return false. Similarly, let's assume that if we had a match on the left hand side, so let's say this node was 2, so this would have returned true, right? So this would have returned true because there was a match. But now let's check on the right hand side of this node 1 on the first tree and the right hand side of node 1 in the second tree. The right hand side of node 1 is a valid value, which is 2, and the right hand side of node 1 is null in the first tree. So again, this is not a match. So again, signifying that if any one node is null and the other one is not, so therefore there is not a match, and then we return false. And if in any scenario, if false is written, then the parent calling function will evaluate if it has received false from any of its child nodes, and if it has, so therefore it is not a match, and that is the edge case. So our algorithm is essentially this: if both nodes are null, that means that is a match. Null is always matched with a null, right? So that is a base condition, then we return true. If just one of them is null and the other one is not, so this is again one of the base conditions. If one of them is null and the other one is not, we return false, since we cannot match them. But if let's say both node values match, so then what we do is, if both nodes values match, we traverse in the left direction. And we check whether there's a left match or not. We recursively check in the left hand side depth wise whether the left child of the first tree and the left child of the second tree are matching or not with the same algorithm. Once we have done that, then we make a right match check. We recursively check in the right hand side of the first tree and the right hand side of the second tree for a match. If left match and right match both are true, then we return true, signifying that there is a left match. The trees are matching in the left hand side and trees are matching in the right hand side, so then we return true. If any one of them is false, that means one side of the subtree is not matching, and therefore they are not the same, and therefore return false. If all of this is finished and we still don't have any match, then obviously return false in the end. So this is our algorithm for the Leetcode question 100, same tree. I hope you guys enjoyed this video. I hope this video helped clear your concepts. Thank you for watching this video, guys. Have a nice day.